This video will show you how to set up a combined transient and steady state model. The recharge will be uniformly distributed and equal to this value. We'll have a stream that is at a head of 0 along the bottom and along the top initially, and those conditions will form the steady state simulation. So that will produce a ridge of high hydraulic head along this part of the model. Then at time equals 0, the hydraulic head will be raised from 0 to 10, and that will create a pressure wave that moves from bottom to top. So we start off with the blank model, and it's 2D, Darcy's law of physics, and we'll start off setting up the stationary model. The geometry is a rectangle, 1000 by 1000. And the boundary conditions, we have two hydraulic head boundary conditions, and we'll also need a mass source. So one hydraulic head boundary condition is here, and that's a head of 0. In the steady state model, we'll have a hydraulic head of 0 along the top and the bottom, and we have a mass source over the whole region, which we select here, and the mass source equals 1 e to the minus 9 times 1000 divided by 10. The same quantities that we used in the steady state model that we did earlier. So we can run this. Well, we first need to, let's see, set up let's set up the storage model, and that will allow us to put in the properties that we need. These are really just the properties that we've used before, so I'm just entering them very quickly. If we run this model, we get this familiar distribution of pressure for the steady state model. Now, we want to change the head and run a transient model. So what we need to do is go up here to the very top, right click, and select Add Study. And this is going to be a time dependent study. So this study number 1, this was the steady state or stationary study that we just used. And now this is the time-dependent study. So what we do is go back here to the hydraulic head boundary condition. We change it from 0 to 10. That will be the trigger for this transient wave that moves. And now we have to use the results from the steady state model, study 1, as the initial conditions for the time-dependent model. We need some more selections here, so what I'm going to do is just run this. This will populate the study with some other entries that we need. And now we expand it, and what we need is this selection here, the dependent variable. So we right click on that, left click on that, and right here, this is the initial values of variables that we're solving for. These are the defaults. Initial value of initial expression equal to 0. But in this case, what we want to do is use the solution from solver 1, which is the steady state model. We can tell it's the steady state model if we go here to study 1, expand it, expand this. You see that it says solver 1 here. So now in study 2, we see that study 2 is solver 2. And when we click on dependent variables, we see that the initial values of variables solved for will be the solution in solver number 1. That's really the key thing that we need. So we'll also change the time step. This is just the default, and we'll go from 0 to 3e to the 7th seconds, and we'll have 30 of them. This is what we used last time. Now we run study 2. There's the solution, and now we want to look at these results. Here's the steady state result, the first one, and now this is the transient result at this particular time. So we can go and select some times here and look at how these colors change. I think this case is particularly well shown if we create a cross section. So let's go in here and put in a cut line in 2D, again from 200 take a look at it. That's where we want it. So we can add in the 1D plot group, select a line graph, and that will be along this particular cut line 2D. I'm going to go back here, cut line 2D, and this is important because the default was to use solution 1, but we want to use solution 2. That's the steady state solution. So we select that here in the data set, and so now when we use this cut line down here in the line graph, we get the transient solution. So here's the result. The initial condition, so right at early time we have this trough, comes back up to the ridge, and then we get this progression of increasing time.